Oh, when you do a decimal? When you do a decimal?
No.
No.
Like on the quiz, on the first couple questions.
Oh, the line on top of the letter. Okay.
Yeah.
That's not, yeah.
Okay.
So, real quick. Because, yeah, you're right. That was confusing to some of us. So if I say A is, all right, look, let's do it this way. My universe is all counting numbers less than 10. Is everybody with me? So what is my universe? 1, 2, 3, 4, 5, 6, 7, 8, 9. You with me? So if A is 2, 4, 7, 9, what is this?
Not
Yeah, what's not in A? 1, 3, 5, 6, 8. There, that's what that means. So that line above a set means not that. And does that make sense why I have to give you the idea of what universe we're in? Because if I said A is 2, 4, 7, 9, so what's not A? You're like, you want me to list it? Well, it's not 1.783. It's not 2.489. It's not the square root of 11. Oh my God, that would take you forever. So I have to tell you, no. Only 1 through 9 could be what it is. So what's not A? All the other numbers from there that I didn't put in A. Does that make sense? So how would you figure out if I just, here, what if I said B was, what you got, Jeff? 1, 2, 5, 7, yes? And let's say I say this, what is not A or B? There are other ways to do this, but personally what I would do is I would figure out what the hell A or B is, and then not it, yes? Not it. No, yes, you guys see what I mean? That wants me to figure out what is not in A or B. So what makes that easy? Figure out what is in A or B, and then list all the other shit. You guys, does that make sense? So to answer this one question, one way to do this is what is this? What's in A or B? Yes. Okay. Help me out, guys. What numbers are in A or B? 2 is in A or B. There's something before that. 1 is in A or B, right? 2, 4, 5, 7, 9. Okay, so what's not in A or B? 3, 6, 8. Do you see what I mean? So I could ask you one question, but to be nice to yourself, you can break it down into parts. If only I knew what the hell A or B was, I could figure out what's not in there. Yeah? Okay. The little line above the letter that represents a set just means everything's not in that set. Okay. Yes? Sorry.
Is there any difference between a line over the whole thing and two broken lines?
Hell yeah. All right. Someday I'll come back. So what have I said? What is not A and not B? What would be really good to figure out before I try to answer this? Look, can you guys tell me what A and B? Can you tell me what A and B is? What's in A and in B? 2 and 7, yes? You guys with me? So when I say and, it's restrictive. It always makes things smaller. Fewer things pass because they have to meet both requirements. You have to be in this set and that set. Or we'll pretty much always make it bigger. Because you could be in either set and you're allowed in. Yes? Are you guys with me? So how do I do not? Why was that relatively easy? Because I can see A and B. So then I can just see what's in both. Why is this harder? Do I know what not A is? Yes? Do I know what not B is? Do I have it written down yet? Have I figured it out? Have I figured out not B? Have I figured out not A? Yes? Okay, I really want you guys with me. This question, this is not A and not B. If I knew what not A was, and I knew what not B was, this question would be easy. So not A, we figured out. Could somebody tell me what not B is? What's not in B? Yeah, 3, 4, 6, 8. No. Yes? Does everybody see where I got 3, 4, 6, 8, 9 from? Okay. Right? It's just all the stuff that's not in B. That's what that means, not B. So all the stuff that's not in B. Now can you answer the question, what is in not A and not B? Do you know what not A is? Yes. Do you know what not B is? Yes. So what's in both? Which things are in both? Which numbers are in both, not A and not B? 3, 6, 8. Do you guys see them? If you give yourself the pieces that the problem wants you to do something with, then you can do it. Right? So some of you guys didn't show me any work, but I figured you probably teased it out, but it's so much harder just to do all that in your head. Give yourself visually what the hell you're working with, right? If I ask you what A and B, that's easy, because I give you A and B. If I ask you what's not A and not B, well, okay, what the hell's not A, what the hell's not B? Okay, now I can see. Maybe? Some of you guys that didn't show me any work, I'm sure you thought in your head, okay, what's not in A, and what's not in B, and you try to do it all in your head. Don't do that to yourself. Okay. Is that okay? Is that better? Is that okay? Guys, if I tell you that X is 3, and I say, what is X plus 2? Can you do that? What is it? 5. Now I ask you, what's X plus Y? Can you do that? Not really. What did I not tell you? What the hell Y is? Okay, good. So when I ask you this question, and I did not tell you what this is, you take a second, you figure out what it is. Does that make sense? And then whatever I want you to do, you could do. Is that okay? Is that okay? I can't remember who asked whatever got me off on that tangent. Okay. Somebody, okay. Anything else from the quiz or from homework or anything? Yes.
Section 2.1, could you go over 18A and B?
2.1
Yeah.
and 18. Oh yeah.
A, B, and C. I guess. But
Oh.
all 18.
Can you do the entire problem, Jeff? All right. So let me show you this. This is something I didn't show you, and I can't remember if the book shows you this. The standard Venn diagram. If I just ask somebody what's a Venn diagram, they're going to draw this. Yes? That's what they're going to be drawing. If this was mammals and horses, well, that would work. That would be different. If this was Democrats and females, does this make sense? Who's this person? What's true about that person right there? They're a female Democrat. What's true about this person? Females not Democrat. Yes. Do you guys? I think I told you how many political parties there are. It's like 53 I know of, but there's more than that. That's stupid. So just female. Okay. You guys with me? Now the one I just said, mammals and horses. Why wouldn't that picture really accurately capture that? If that was horses and this was mammals, what would this be? A horse that's not a mammal, right? And I should have told everybody we are talking about Earth, okay. Not fantasy land or whatever land is in whatever book we read. So another way I could draw a Venn diagram is, what's true? Is every mammal a horse? Is every mammal a horse? Are you a mammal? Are you a horse? So is every mammal a horse? No. Is every horse a mammal? Yes. So all the horses are mammals. That's another way to draw a Venn diagram. And that Venn diagram would mean all of H is in M. You guys see what I'm saying? That Model does not work for every situation, obviously, because that would lead to weird things. Is that okay? You guys see what I mean? So this idea, and then of course the last major way to draw it would be where they don't even meet. So if this is F and this is W, what is F and W? Yep, empty. It could be figs and watermelons. There are no watermelons that are also figs that I know of. I don't know. So the standard way we draw a Venn diagram is that way to leave it open that they might have some overlap. I have to draw it differently if they don't. If I draw horses and mammals with just an overlap, then that leads to a horse not being a mammal. Okay, what the hell? Venn diagram's got to represent reality. Yes. Are you guys? You guys see what I'm saying? So a lot of times you guys don't even know the flexibility in how to draw these things. So for this problem, you're going to have at least one of them is going to be drawn a different way than this. This first one says, what's got to be true about the circles? Yeah, the intersection cannot be empty. So that one's kind of silly because the standard way we draw it is to show that the intersection is not empty. There you go. So for part A, just standard Venn diagram answers it. Look at part B. Part B says A or B is A. Stay with me. The way I think about or, if I said, just to go back to my dumbass example, females or Democrats, right? Start with all females, and then female or Democrat says, take all the Democrats we haven't included yet and shove them in there too. Yes? You guys with me? This one says, if I start with A and add all the stuff that's in B that I didn't count yet, I still have just A. Did I add any new information then? Did B add any new information? No. So it's like me saying horse or mammal. That is mammal, yes? If I start with mammals and I add in all the horses, I already had all the damn horses in there. Does it give me any more information? So if you're paying attention, I just told you the answer to part B. And then see all this. I'll leave it to you guys. Got to be part of that for you to do. Anything else? It could even be a follow-up on what we just talked about. All right. You guys know, do you guys know what to do if you're stuck? You know what I mean? One thing you could do, if you're by yourself, and there's no way to go anywhere, you could look for a similar problem in the A section, because all those answers are in the back. You guys got it with me? That's what I would do. First level is I'm like, what the shit do I do? Find a problem that's like the one you're looking at and see what the answer is and see if you can kind of like, it helps you figure out what you're supposed to do. Does that make sense? That doesn't always work. So then you reach out. Then if you're on campus, you go for tutors, you go to see my office hours. If none of that shit works, you say, hey, Mr. Waller, I need help. I can't go to anything. Help. And I'll say, when are you available? We can do a Zoom, right? Okay. You stop for a minute. I just need to remind you guys, you're not like hanging out there by yourself when you're doing this homework. You're surrounded by people that want to help you. Okay. Anything else? All right, so let me ask you this. Oh yeah, shoot. Oh man. Do you guys remember the shirt that I wore on Tuesday? Okay. One of my colleagues, I told her I wore this shirt because I thought I was going to make it to chapter 1 and I didn't make it, so then she took a picture and sent it to me of me in the shirt about for Ellery. Shirt was 2 minus 1 and said I literally can't eat it. Yes. Did I talk about that shirt at all besides that? Okay. So let me ask you this. Every even number, you can write it how? How can I write every even number? Not the definition, but how can I write it? So what is the definition? Let's start there. What is the definition of even number? What makes a number even?
Divisible by 2.
Oh, I was gonna curl up on it. Divisible by 2, yes. That means, now think about it. Give me an even number.
12.
12. That's even because you can break it up as 2 times 6, yes? So what's true about every even number? You can break it up as 2 times something. 2 times some counting number. Are you with me? Okay. So I can represent, if I realize that n is a letter that we use to represent natural numbers, which are 1, 2, 3. It's a little side note. Every even number is in this form. Is that cool? That is the first level thing that algebra does for us. I could represent, and how many even numbers did I just write down? All of them. I just wrote down an infinite number of numbers right there, and it took me like less than 2 seconds. So that's what algebra does. It lets us represent an infinite number of things very quickly. And then we can work with an infinite number of things. That's what you do when you solve freaking equations. You are working with an infinite number of things. So how do I represent an odd number? Now listen. One thing I get from students, and some of you guys already know the answer because it's on my shirt. But one thing I get from a student is they'll say, well, an odd number would be 3n. Do you understand on the surface that makes some kind of sense? But do you see how it doesn't make any damn sense? Because what's 3 times 4? That's not odd. Do you see what I mean? So, odd numbers are a little weird. Can somebody help me out? Start counting even numbers. Go for it. 2, 4, 6. How are odd numbers related to that? Like if I had a number line, 2, 4, 6, how could I shift things so I can get all the odd numbers? Shift everything by 1. So if I have an even number, and let me see if you guys are cool with this. If I write this, that is specifically the odd number that's next to this one. Do you see what I mean? I really need to see what I mean. Like somebody, so 12, right, was the one you told me earlier? If I do 12 minus 1, I get 11. Yes? So this would be the odd number that comes right before this even number. Are you with me? Somebody give me an n. Give me any n. 15. So 2 times 15 is what? 30. And what's the odd number before that? 29. 2n minus 1, yes? So if I'm going to write every odd number, I have to use a different letter. So now those are independent from each other, yes? If you give me a value of n and you give me a value of m, I just get 2 numbers. One of them's even, one of them's odd. They don't have to be related to each other. Does that make sense? Okay, how we doing? You guys are like, oh, this is great. I thought I was done with it though. What do you guys think happens if I add an even number to an odd number? How could you investigate that? I mean, well, what's the first thing you think of? If I say, what happens when you add an even to an odd? What's the first thing you can kind of do? Yes, you just do an example. What's 2 plus 3? 5, and that happens to be what kind of number? Odd. Is that good enough to go, everyone is odd? Nope. So what do you do then? Do another one. Give me an odd number. 7. Give me an even number. 12. What's 7 plus 12? That's odd. Now we got 2 examples where the answer was odd. Is that enough evidence? We could have just happened to pick 2 of the situations. I need you to understand. So how do I actually prove? How do you guys feel about that hypothesis? An even plus an odd should come out odd. I'm not asking you to tell me definitively what, but do you feel like the answer is always going to be odd? Anybody? And you're all like, I don't even know what the hell's going on here. What happened? Did I fall down to my head? Am I really here? So the way I prove what the shit happens is I take every even number and add it to every odd number. Yes? I can't possibly make a list of all the possible odds plus evens. Good Lord, there's an infinite number of evens, an infinite number of odds, and an infinite number of ways to pair them up. So there's an infinite number of infinite ways to take the infinite numbers and pair them. Holy shit, that's a lot of infinite. So what can I do instead? Take every even number. Add it to every odd number. Yes? Now what, math boy? All right. What can I take out of these? Is there a common factor I can take out? And what am I left with? And what is n plus m? It's just some counting number, correct? What is in this? What kind of number is in this form? What kind of number is one away from an even number? Odd number. So odd numbers have this form, correct? So we started with an even plus an odd, and we got it down to the answer is an even number minus 1. So what kind of number is it always? Odd. So if I do a few specific examples, that's not enough to prove something. Now, just to calm everybody down, I'm kind of opening this discussion with this. You're not going to be doing a ton of problems like this yourself. You with me? But this is an example of we want to investigate a situation. I could use a variable to help me investigate that situation. Yes? There's really no other good way to investigate this. Doing specific examples won't ever be enough. Okay. So, let's take a step back. One nice thing about chapter 1 is algebra is just one possibility. So, has anyone ever taken an algebra class and there's a word problem and you just figure it out without using algebra? I don't know. Can you guys remember those days? Was your teacher happy with that? No. And very often the student doesn't understand. They're like, what the shit? I got the answer. But I always tell my students, what's the name of the class? When you're in an algebra class, the name of the class is algebra class, so you're supposed to use algebra. So like, my example is if you're in driving class, and the final exam is to drive to the mall. So you walk to the mall, and you say, I'm at the mall, I passed. No. I made it to the mall. No, the point was to drive. You guys kind of follow? Because I understand students get upset when they get the right answer, but they did not use the correct process. Yes? What's really nice about chapter 1 is we're going to have a big list of strategies, and you could use whatever strategy works. That's the real world. Algebra is a really strong tool, but it's just one tool. There's other tools we can use. So let me ask you this question. This is more, well, it's a little more visual than just mathematics, but it's definitely mathematics. Where's your example, Jeff? I don't know, Jeff. There it is. No, it isn't. There it is. Okay. Here's the idea. Can everybody make this little diagram? Shit. Okay. You can make it even better than my poor little triangle somebody dropped. In the boxes, put 41, 36, and 49. So here's what I want to have happen. I want you to put numbers in the circles so that any two circles add up to be the number in the box between. You with me? I want numbers in every one of these circles where the number in the box is the sum of the circles on either side of it. Yes? So this could be like 20 and 16. But do you understand why it might not be 20 and 16? Okay. Go ahead. Try and figure it out. I'll wait. Does anybody not understand the rules? All right, say it one more time. The numbers in the circle. You get to pick numbers for the circles, but whatever number you put here and here, better add the 41. And whatever number you put here and here, better add to 36. And okay. So let me ask you guys, I know you're not done necessarily, but can somebody share with me what you're doing to try to answer this question? And this, you can't be wrong unless you say something like, well, I wrote the number yellow, and then you're wrong, that's wrong. Right, you can't be wrong, yes.
I can tell you what I did.
Yeah.
I just did 36 because it's even.
Yeah.
18, 18. And then
Oh, okay. So you put 18, 18, and then you saw what that made this number? And did it work? No, okay. But is everybody else sort of doing something similar? You didn't have to start with 18, 18, but aren't you first guessing something? And then you're checking, right? You guys have heard guess and check. You guys have heard guess and check, yes? Okay. When you're in algebra class, that's the last thing your teacher wants to see. Is guess and check. But we're not in algebra. We're right now in the section about problem solving, and guess and check is a valid problem solving technique. So, does somebody feel like they're getting close? Is everybody still trying? I'll see if you guys, I like it. Some of you guys very interestingly have no paper in front of you. That's neat. I like everything happens here, man. I want future me to see anything I'm doing right now. That's a choice. So just real quick, if you did put 18 and 18, this would require it to be 23, but then that wouldn't work for this. So then you realize, okay, no two circles can be the same number, right? Because that wouldn't kind of like swing and work for the other situation. You with me? Okay. So now we've learned something. So our guess and check, we have learned something. Oh yeah, so I can't have two circles with the same number, because then they both can't make the other boxes. Okay. Not really sure how to ask you guys to help me with this. Did you guys like pick a circle to start with and just start guessing stuff and then kind of working out? Yes, good. It wouldn't work to guess complete. If I just put 11, 38, and 19, why is that a silly way to guess and check? That's guess and check, correct? But why is that a silly way to do it? If I put 11 here, could this be anything it wants to be? No. Okay, good. Okay. So there's different levels of guess and check. There's just pure guess and check, where you just throw numbers, just throw them in. This is more contained. You got to use the restrictions, yeah.
I got it, but I literally just put on random numbers.
For all three circles.
Yeah, but I got it.
All right, you should not play the lottery because you've used up all your luck on that.
But yeah, I just put like 14 and 22 on the bottom, and then I put
Now, real quick,
7 on top.
you did not pick 14 independent from 22, right? So you didn't really pick them all at random. You picked 14, which required the other circle to be 22, right? Okay, so you didn't just pick all three out of nowhere. That's what was going to trip me up if you did. That would be like, holy shit. You with me?
Yeah.
Okay. So now, just giving away the answer, but let's see. I'm going to purposefully So if I put 14 here and 22 here, become a thing. That would mean this would have to be 19, but then this doesn't work, right? But if I put this 22 here and I put this 14 there, that doesn't work either.
Yeah, it does, 'cause the top is 27.
Huh?
The top would be 27, so that-
Oh, I see, yeah, I gotta change that number. So then 14 and 41, so this will be 27, 27, 22, 49, good. What did I get? Hopefully I got the same thing. Yes, cool. So this, as you guess, you refine your guesses based on what you see. So for example, can somebody share with me, did you guys keep track of your guesses, anybody? Yes, what was your first guess? Which circle did you first put something in for?
I split 36, so I did 18.
All right, what was your second guess?
After that, I did 20 and 60.
So you put a 20 here?
Yeah.
Okay, 20. So that would make this 21. And that would make, and then this has to be 16 this way, but it has to be 28 this way, right? So then that helps you figure out this has to be smaller so this could be bigger. So I have no idea, as you guys were guessing and checking, you should have been trying to refine your guesses, yes? So that's one thing you can notice, the way you guess is like, oh, this one's gotta be smaller, so this one could be bigger, because 49 is the biggest number, so I need those circles to be big, yes? So you start to notice things like that as you do the guess. So it's random, but then you refine it as you go. And it's based on the restrictions of what it's gotta live in. So there are different levels to guess and check. One level is just pure guess and check. And I forget what this book calls that. Here we go. Oh yeah, that's right. This book is silly. This book calls guess and check. It calls it guess and test. I'm not gonna say that, because I don't think of it that way. Yeah, okay, that makes sense. The first level is random, guess and check. The second level is systematic, guess and check. And the third level is called inferential. The level we were actually using for this was inferential, because as you guessed, you refined your guess by inferring what has to happen. So like when I put a 20 there and a 16, I said, oh shit, this has got to be bigger, that's got to be smaller, so this could be bigger, because that's the biggest number. So I'm inferring something about what must be true. Okay. All right. So I got a little handout I'm going to give to you that's going to give you something to try out. Second thing, so number one, we have guess and check. That is a strategy for solving a problem. Secondly, we have draw a picture. So for example, here's a problem I picked out. Let me see if I can make this make sense. Where'd it go? Yeah. Place 10 stools along 4 walls. So that each of the 4 walls has the same number of stools. Does that make sense? So I mean, if I physically put 4 chairs just in the middle here, that wall has 4 chairs. Yes? One thing I will tell you, what if you put it in the very corner? That 1 chair counts for 2 walls. So try to draw a picture to figure this out. I want you got 10 stools. So what you can do is you can have the room is a big rectangle and the stools are just circles. You have to put circles along each wall. There has to be a total of 10 of them, but you need to end up with all four walls having the same number of stools. If you put them in the corner, you have walls sharing a stool, yes? So try to draw this out. So one way to do this, here's my room. And I put 2 here, and I put 3 there, and I put 2 there, and I put 3 there. That's 10. Do they all have the same number of stools? No. Okay, so go. Try it out. It's a silly way to do it. Which will not work. So now you can rearrange the stools. Use the corner thing I kind of gave away, yes? So I'm almost certain at least one person in here is thinking to themselves, how is this gonna help me teach? But what is it we're talking about? If you had a group of students trying to do this problem, what are they getting out of it? If you have a group of students trying to do this problem, what are they getting out of it? Are they getting anything out of it? Just give them something to do, keep them out of trouble? Or what? What are they getting out of it? One thing is spatial reason. Right, draw them correctly, draw little stools in there, reorganize them, right? Another thing is they're starting to develop some creative, critical thinking skills. If I do this, it didn't work. Why didn't it work? How do I improve it? What different thing can I do? Yes? Just getting used to having an issue that needs an answer. Let me play around with it until I get there, right? There's also this thing called math stamina that I talk about with my students a lot. When you have this word problem and you're trying to set things up, you get to a point where like, all right, I've done enough. Let me go to the next part. So it's the stamina to get through a problem. Yes? Some of you guys are like, I am out of that. My little stamina bar is all the way down. Jeff? Anybody feel like you got the answer? Does anybody feel like you got the answer? Okay. You feel comfortable coming up here and explaining it?
Sure.
Yeah, so then everybody can hear somebody else talk? Like Easter guy.
Oh, I can see, okay. So, I drew it this way, obviously. I tried putting one on each corner, but that obviously didn't work. So I said, I could still put, each wall could still have a stool, so I put them opposite corners, and then, so that, what's left over is 8, and that's divisible by 4, so I just kept going, put one on each wall. And then, so then there's 2 here, 2 here, 2 here, 2 right there, so they're still even. And just added 1 more. And then counted them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Yeah, kick ass. Cool. Anybody else get that same answer and just wasn't sure it was right or not or something? Yes? Did you get it a different way?
Just, yeah, I was gonna say, I had an orthodox way. I just divided 10 by 4.
Yes?
I had 2 with 2 left over.
Yes.
I'm like, okay, well, I can do 2 stools per wall, but I'd have to split the last 2 stools.
Kick ass. So this is sort of like half a stool for each wall it's sitting next to, right? So that's related to the remainder. Oh, that kicks so much ass. Both of you guys had these beautiful little elements of math that I didn't even include the way I did it. The way I did it was much less mathematical, which is funny. But just a little side story. I majored in math and then I took physics, and when I was in physics, I just explained an idea, and and the guy came over and he said, are you not comfortable with math? No, I am. I just like to explain stuff instead of just relying on math stuff. But that brought tears to my eyes, because both of those are beautiful, using mathematics. Do any of you guys feel like you, as you were trying stuff out, you started to figure out how to incorporate that clue I gave you about the corner, right? And I like the way you put everything in the corner just to see, and that's beautiful. That's systematic. So you try something and you see if it leads to an issue, and then you say, well, it can't be that. Yeah? You have a systematic way of doing it. You try something, you see, and you're like, nope, can't be that. Let me try something else. All right, let me stop for a minute. How you guys doing? This is a very interesting moment for me as a teacher, by the way, because did I tell you why I do chapter 2 and then chapter 1? Because the very first time I taught, I did chapter 1 first, and that was like a brick wall for people. And you guys are feeling it, it's just a little blunted, because now we've gone through, even if you hate sets and all that stuff, there was some stuff in chapter 2 that was fun, and even if you know, it's neat drawing all this stuff, maybe, hopefully, I don't know. It just helps us ease into the class before I hit you with these problems, yes? All right. So drawing a picture, now obviously sometimes, in that very first problem, there was a picture drawn for us already, but you could argue it's drawing a picture. So a lot of problem solving is using multiple methods at once. Then the third method that's talked about in section 1.1 is use a variable. So, in this vein, you guys have heard this kind of thing before. Can everybody pick a number? Everybody pick a number and write it down on your paper. Okay. I want you to add 4 to that number. Agree with me? So if you start with 7, you should have 11 now, yes? You could even start with negative, but I'm pretty sure nobody started with that. Start with pi. No, don't. You can use any number you want to. Now triple what you have right now. You with me? Multiply what you got by 3. Now subtract 12. Now subtract twice your original number. Everybody got their original number at the end, yes? You did that right. No matter what you do, what did you guys start with? What number did you start with? 4. And you ended up with 4, yes? What number did you start with? Sorry, anyone? 36, and you ended up with 36, yes? And you're like, when I said triple, you're like, oh, great. Okay, so on. Everybody else okay? If I would have done that differently, I could have made everybody end up with 5, and maybe that would have hit better. Have you guys ever seen something like that? I saw it, to be really honest, I saw one recently. I don't remember who sent it to me, but somebody, probably one of my colleagues, sent it to me, and it was this guy wearing the V for Vendetta mask. And he said, I could read your mind. If you pick a number, blah, 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 you have a 5. You know, like, come on, that's dumb. Because it's just this shit. Now, I put up here use a variable, yes? How do we prove that no matter what number you pick, you'll end up with the number you started with? What if you picked a negative number, it wouldn't have come out that way? You with me? Did anybody start with a negative number? I didn't think so. What if you pick a fraction? What if you pick a fraction? Maybe it doesn't end up being itself. You with me? Everybody picked a positive number, yes? I think everybody picked 0. Okay. Are you guys understanding what I'm saying? Even though I have a bunch of examples where you all ended up with the same number, it doesn't mean that would work all the time. There are certain numbers you guys didn't pick. Maybe it doesn't work for them. How the shit do I prove this then? How do I prove it's always going to come out to be the same? Look what I wrote in my paper. So, when I say start with a number, if I want to prove it works no matter what, I actually have to start with every number. And so to even be better than what I wrote down, let's all write x, yes? What did I ask you to do next? Add 4, so that would be x plus 4, yes? Then I told you to triple it. And of course, how do you do that? 3x plus 12. Okay. And then I asked you to subtract 12, right? Is everybody with me? And then I asked you to, and what right here, what I should have done is I should have said divide by your number. That would have been a little more tricky, but I said subtract twice your original number. What is 3x minus 2x? X. Yeah. 3x's, take away 2x's, just x. Yeah. That is the proof. That is how you prove that no matter what number you start with, you end up with the same number. Yes? And do you guys understand? If I would have said, if past Jeff would have just been a little bit smarter, right here I could have said divide by your original number and everybody would have gotten 3. If you divide by the original number right here, you would have gotten 3. Everybody would have gotten 3. And that would have been like, ooh, everybody got 3, yeah. I guess, okay. Has anybody ever seen this? You all have heard that shit, yes? Start with your age. Now add the number of TVs in your house. And you get 7. It's like, all right, whatever, dude. You just did math. Who cares? That's all it is, right? So you can make it do whatever the hell you want it to. Okay, maybe. Okay. So, I am going to have you guys work on some stuff. Let me give you this and I'll tell you which problems to work on. I didn't put cute little things on here, I'm sorry, but we'll figure out proofs somehow. All right, guys, so let's do number 1, 2, and 3 for the moment. Let me see. All right. Okay, that'll work. Let's just do it this way. Everybody's cool with this. There's 3 of you there, 1 of you there. So, like, can you guys work, all 4 of you together? Can you 3 work together? You 3? Yes. You 3 there, you 3 here. Yes. 3, 3. Oh, 4. 4, 3. Okay. And then 4. And then, woo, 5. Alright, so y'all turn around or something, however you want to work it. So you 3. I'm not sure what you're looking at. I mean, move yourself and work together. Alright guys, I want to discuss something interesting with you. This always happens. These questions are not obvious. Do you guys agree with me? Okay. It's really interesting, the human approach to a problem when we're not sure how to do it, especially as a student. You don't allow yourself room to just try anything because you have this what do math teachers normally kind of do? No, you've got to do it the right way. You need the right answer, you know. Hopefully no math teacher was just like that, but that's the message that comes across. You with me? A lot of the time. This, you need to leave room for students to play because, for example, a lot of the ways I teach math, I stole from students. So I had ways to teach it, and I would teach it, and then I would see on a homework, somebody would do something like, can you explain this to me? And then tell me, and I'm like, oh, that's neat, I'm gonna teach it that way now. You know what I mean? So not as bad as like a comic stealing somebody else's joke, but I'm like, this is just a great way to explain it. I couldn't think of it that way because I am one person with a perspective that can only be bent so far. Are you with me? So one thing about group work is somebody could say something, and if you actually bring it into yourself, you're like, I didn't even think to look at it that way. Another thing with group work, I was gonna ask you guys, what do you think I try to get out of group work? You want to be a teacher. What does that mean? Fundamentally, you need to be able to do. Explain shit, right? You have to be able to explain shit. And some of you guys, I don't know, you could say, well, I'm doing a terrible job. No, I'm sorry. I'm joking. But you have to be able to explain stuff. So in a group, you see how to do something, you have to be able to explain it to the people in your group to the point where they can understand you. Which is why I always say, if you want to be a teacher, you get out and you tutor as soon as you can. I remember I tutored at, it was called Newtown Road Elementary, it's on the East Coast. And their mascot was a Roadrunner, and I'd go there like 2 days a week after school. I'd go over there and tutor little people in math and whatever. I was even tutoring social studies, and I was like, oh, look at me go. Huh? But it was just a really good experience to understand how much I could push myself to explain a topic, a concept. You guys kind of, and that's important right now for each of you to see, okay, this job requires me to explain something in a way that I hadn't even thought about at first. Can I do that? When you're about to go into any job, can you do what the job needs you to do? You need to put yourself in situations to explore that. Does that make sense? So another thing with this whole experience is the frustration and how to try to mitigate that to some degree. There's only so much you as a teacher can do, right? But I try to remind people, I'm not gonna grade this shit. If you never want me to see your work, you never have to show it to me. When we do things like this, you with me? So there's zero stakes. So it's just pure playtime. And when I say that, I don't mean draw a duck. I mean, just try whatever shit comes to mind. This is so much better than algebra class. Because in algebra class, you have, where's your x? Where's your equation? This is just, can you come up with a way? The first one's like, there's 3 ways to do this damn thing. Can you come up with any of them? Yes? So it doesn't have to be algebra. Are you guys starting to understand? So, really little kids, they want to play with everything, including math, including everything. They're not jaded yet. They're not. So you want to give them room to do that. And they'll make mistakes, but they will sometimes have these beautiful little insights. And you want to catch that and say, yeah, totally, you got the right way to look at it. Do you kind of follow? But if you don't give them room to do that, you're never going to let them get there themselves. Okay. All that said, I'm really sorry if that was terrible for anybody. Some of you guys seem very frustrated. Let go of the getting the answer. All right, and let me say this right now. When I grade chapter 1 homework, getting the answer is icing. I'm looking at the way you approach the problem fundamentally. Are you with me? Most of the points will be based on if you showed me your thought process and what you're trying to do. If you did not get the exact right answer, that's going to be the least of the points I would count. Does that make sense? And that's why do I do it that way? Because that's the way it should freaking be done, according to me. Because the most important thing is thought process, right? We're not building bridges yet. When you build a bridge, you better get the right answer, or people are going to die. But we're not building bridges yet. Right now, it's thought process. Okay. I'll stop. Sorry. So, what's neat is, as I was walking around the room, if I put all the groups together, everybody got the 3 different ways for the first problem. Can somebody share one way you did the first problem? As I try desperately to find any paper I can write on. Anybody did the first problem? I know somebody did. What'd you get? How'd you guys do the first problem?
So I guess this goes along with guess and check.
Yeah.
We divided 78 by 3.
Yes, okay. So that was one method that a few groups didn't come up with. Which, who cares? I need you to understand what I just said. Who cares that you didn't come up with it? But do you understand why that would work if you didn't come up with that idea? 78 divided by 3. I have 3 numbers that are all really close to each other. Let me assume they're all the same number, and then that gets me close to the right number, yes? So 78 divided by 3, what'd you get?
26.
26. So if they were all the same number, it would be 26, 26, 26, yes? But they're supposed to be consecutive. So if you make this one go down, then this one can go up. And there's your consecutive, right? That is actually the way that I have students do this problem when this problem is in algebra class. Obviously, you know what I do. I take off most of the points and I say, no, you didn't do any algebra. For us, this is a problem that needs an answer. Who gives a shit if you use this tool versus that tool? Yes? But when you're in algebra class, you're specifically learning about that. It's sort of like if you take screwdriver class and you come in with a wrench. You're like, no, this is screwdriver class. You need to learn how to use the screwdriver. Okay. Yes?
Does that count as guess and check, or is that more?
No. This is its own idea. Every one of them might have an element of guess and check. But this was beautiful. This was actually, well, let it be the same number. Let me work it out that way and then see how close I get to something. So it's got elements of guess and check, but this stands alone. Guess and check would be, who did guess and check? Complete guess and check. What'd you do? Anybody? I know somebody did. All right. 18, 19, 20. Is that consecutive integers? Consecutive numbers, sorry. Yes. What's 18 plus 19 plus 20? 57. Too low. So I can do systematic guessing. Now I can take that and go, oh, that's too low. Let me just raise my numbers up 24, 25, 26. That would be 75. Oh, I'm getting close. Do you guys see what I'm saying? That is guess and check, but not random guess and check. It was kind of random at first, but it's systematic. If I take a guess, I see how far off I am, and I adjust my guess. Yes? You guys with me? So I'm trying to show you different ways you could have tried algebra problems could have been valid. And if you had a good algebra teacher, they would have said, that's actually not a bad way to solve this, but you're in algebra class, you have to use algebra, right? Okay. Anybody think they got the algebraic approach that hasn't said anything yet? You got it?
I think it's x, and then x plus 1 plus x plus 3.
All right, good. So you have 3 numbers, and they have to be consecutive. So whatever number you come up with first, you add 1 to it, and you add 1 to it. Those are 3 consecutive numbers, right? And then those 3 consecutive numbers have to, when you add them, you have to get 78. So I get 3x plus 3, 78. Now, very quickly, here's a connection with what you did. If I divide, can I divide all of those by 3? Can I divide everything by 3? I could, yes? And that's related to this approach, yes? But if I'm just doing pure algebra, what would I do next? Subtract 3. And of course, 3 watts is 75 cents. 25 cents, yeah. So x is 25. So what's the next number? 26. And what's the next number? 27, yeah. So algebra is an excellent tool. It just gobbles up freaking problems left and right. Is it always the best tool? Hell no. Hell no. Sometimes it is. Very often it's not the best tool. Okay. You're not used to hearing a math teacher say that, right? Well, that's reality. What about number 2? Who have I not heard from that wants to give me an idea about how you approach number 2? Anybody? You're all like, I'm going to trademark my approach, Jeff, so nobody can actually hear about it. Yes?
I don't know if this counts as like guess and check. I feel like it kind of worked, but I just took the perimeter 58 and I divided it by 2 because there's 2 lengths and 2 widths.
Okay.
And then that got
Okay, wait, let me catch up. Wait. So you took 58 and divided by 2, because in your head you're thinking 2 lengths and 2 widths.
Yeah.
Okay.
And then I literally just guessed and did, like, was just adding random numbers and got 11 and 18.
Okay.
And so I kind of plugged those in, but I'm not really sure if those.
So why was 11 and 18 instead of 12 and 16
That's
or
the
17?
thing, like, I don't know, I just like plugged those randomly in because it fit with it fit with 15.
So real quick, if you draw a picture and you have a width and a length and a width and a length, all the way around is 58 feet, right? Yes. Halfway around is 29. So the two numbers have to add to 29, but they also have to multiply to be 198, yes? Then it becomes a number game. And that, I think, is what you were doing, potentially. I don't know.
I didn't really finish the problem, but that's kind of as far as I got.
All right, let me stop for a second. You guys are all with me. This is the way I do it. When I'm teaching algebra and we're going to do this into an equation, I cut the perimeter in half, because then I just have one width and one length. If all the way around is 58, then one width and one length is 29. So then I need two numbers that add to 29. And what's the area of what I've drawn here? Don't say 198. What's the area of this? Length times width. So I need two numbers that add to 29 and multiply to 198. You guys with me? And then it's a number puzzle. Figure out what two numbers. So then, like you could have done 12 and 17, but 12 times 17 is not 198. That can't be the answer. It's pretty close. So then 11 and 18, bam. Yes. Are you guys all with me? A little bit. So pure guess and test, like random guess and test, that would be insane. It's like 30 and 15, no. 22 and 98, no. No, you need some restrictions. So systematic guess and check, much better. But then inferential, because you're like, if you go the wrong way, you get too small, that means you have to go the other way. So it's inferential, because you can see the effects. You can see how far away you're getting from the answer and go the other way. Did anyone else do this a different way? Or does anyone, nobody wants to share? You're all like, if we just stay quiet, maybe he'll let us out even earlier. Thanks for being honest. That's exactly it. Okay, I understand. I won't take that personally. I'll be fine. All right. If I want to do this, if I want to do this algebraically, y'all agree with me? 2 lengths and 2 widths. So if I divide it by 2, I actually end up where you were. Yes? And then the area is length times width is 198, and I pretty much end up in the same place where I was. I have to get two numbers that do those two things, right? Now I'm not expecting anybody to solve this for W, plug it in here, do a quadratic. Holy shit, that's like the pure algebraical approach. Okay, so obviously this is no good. This is better, this is best. Oh, well there you go, best. And then number 3, understandably, number 3 was one of the harder questions. And the first 2 weren't exactly simple. I saw one person's approach, which was really nice. I like the way they did it. One way I would do this, there's a method that we haven't gotten to yet, but it's called solve a simpler problem. So what that means is, what if instead of being 180, what is it, 180 feet long? What if it was 18 feet? How many posts could you fit? If there's a post here, how far do you have to go before you put the next post? 6 feet? So then I went too far, Jeff. Oh well, I'll be all right. My picture sucks. All right, let me give myself more room. So I put a post here, I gotta go 6 feet, put another post, and then I can go 6 more feet, put another post. If I go 6 more feet, that's the corner, yes? Now, is this gonna be the right answer for the problem that gave me? No. But do you understand, if I do a simpler problem, if I decrease the size of the numbers and I work on that, it's easier to see what happens. So here, if I keep going, post, 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 okay. So how many posts did I end up with? 1, 2, 3, 4. 5, 6, 7, 8, 9. 4 plus 3 plus 2. You guys see that? So this sort of incorporates, make a picture, solve a simpler problem, and then this is kind of related to find a pattern. I would expect a lot of people to do it this way though. I just want to share with you the way I would first start to attack this. And then I can kind of go to 180 feet and I can build what I just discovered. Real quick, what is 18 divided by 6? 3. This is kind of related to the stool problem because 1, 2, 3, 1, 2, 3, 1, 2, 3. Do you see how it is? Each side gets 3 in a way. If you assign the corner to this one, that corner goes to this one, that corner goes to this, they all have 3. That's one kind of way to look at it. So I did like the way you did it. Okay. So what is the correct answer? So yeah, does anyone think they got, I know one group, yeah, what'd you guys get back there? Yeah.
I got 720.
So we got one group got $720. You guys got 696, which is neat. Okay. So let me ask you this. 18 feet on a side ended up with 3, 3, 3, right? Ended up with 3 times 3, which is 9 posts. Are you with me? A little bit? So 180 feet. Now how did I get 3? Because I divided by 6, because I had to be 6 feet apart. I don't know if you guys are really with me. So I picked the number 18, because it's related to 180, and it's related to 6. And I knew those were important. And then I could just set it up. It's a lot easier to work with 18 feet. There's a lot less posts. The picture's easier. Yes? Let's see if you guys really hold me. 18 divided by 6 is 3. So I had 3 groups of 3 there. Yes? 180 divided by 6 is 30. So I end up with 3 groups of 30, which is 90. And then 90 times, what was it, $8 each? So the 720 is right. So you guys were missing some posts somehow. Okay. So very often somebody will do 180 divided by 6. Why does that make sense? Does the posts have to be 6 feet apart? Yes. Does that make any sense? If the posts have to be 6 feet apart and I'm going 180 feet, 180 divided by 6 seems to be a good idea. If you stop and think though, that wouldn't count the first post. But the fact that they kind of fed into each other, yes? That first post gets counted and then that last post gets counted here and then so that it's still, so if you do a simpler problem, you realize, holy shit, if I just take the length of the side, divided by 6, that'll tell me how many kind of like belong truly to that side, and then these 3 belong truly that side, and these 3 belong truly that side. So if I had one 180 feet, there would be 30, 30, 30. So there would be a total of 90 fence posts. Now listen. That one was a beast. Yes? That's not an example of a problem you're gonna have to do graded on your own. Yes?
I did differently but similar.
Go ahead.
So I did 180 and then because it's a triangular field, I did that times 3. And then from there, because it's 6 feet along each side, I divided that from 6 and then multiplied that answer
Oh yeah.
by 8.
I did 180 divided by 6, and then multiply that by 3. You did 180 times 3, and then divided that by 6. Yeah. So you did like all of those sides at once.
Yeah.
I did one side and then tripled it. So the math is like, I don't care what order you do it. Yeah. All right, guys. Sticking to my promise, that is enough. Everybody got a practice test, yes? Oh, if you didn't get a practice test, you might not have gotten your quiz back either.
So can I give this back?
Where have I
to
put
you?
everything?
Like
What's
with
that?
the corrections
Oh, yeah,
back?
right there. So coming up, if you need a practice test and your quiz. What have I done? with all the practice tests. Wait a minute. There they are. Alright. So you need your quiz also, right?
Yeah.
What's your name again?
Gabby or Gabrielle? I don't remember which one I wrote on there.
Ah. So there's this, you can make corrections, you could get 9 points back. That's the practice test.
For the homework, it's just we write it on another piece of paper and turn it in, right?
For the corrections?
For the homework.
For the homework corrections.
No.
For homework.
For the homework.
Yeah, you write it on paper and turn it in. Yeah, just like that.
Okay, thank you.
Yep, sure.
I need to practice test my quiz. Thank you.
Are you, what's your name?
Enoch.
Ina.
Thank you.
So you can make corrections if you want to. Oh yeah, thank you. Sorry, I forgot I had thrown that out. Yeah.